Bismillahirrahmanirrahim. Hi, Assalamualaikum and a very good morning to our beloved panel, my supervisor and my co-supervisor, TS Dr. Maria binti Awang and TS Muhammad Syafiq Shazwan bin Mustafa. My name is Faladera bint Abdul Samad, metric number AN180008. Today, I'll be presenting a study on issues of solar energy system on safety, health and environmental SHE aspect for my Bachelor Degree Project 1. Content of presentation. These are the content of my presentation, starting with introduction, background of study, problem statement, objective and scope of study, significance of study, literature review, research methodology, and conclusion. Introduction. Solar energy is one of the cleanest forms of energy resources and considered as a green source of energy. Solar energy benefit ranges from low carbon emission, no fossil fuels requirement, long-term solar resources, less payback time and other. However, like other power generation sources, solar energy has also some safety, health and environmental SHE concern. This study presents the overview of solar energy technologies, addresses the SHE impact of solar energy technologies to the sustainability of human activities, and recommend the possible ways to reduce the effect of potential hazard of widespread use of solar energy technologies. Background of the study. With the power sector emitting the most heavily dependence on fossil fuels will rise CO2 emission. In 2011, power producers in the United States utilized 36% of the country's energy from fossil fuels and released 41% of CO2 from fossil fuels burning. Renewable energy and nuclear power are the world's fastest growing energy source, with both rising at the rate of 2.5% each year. However, due to poor efficiency and other SHE concerns, solar will contribute less than wind and biomass. In the manufacturing process of PV solar cell, very hazardous elements such as cadmium, lead, nickel, and other chemicals are employed which have been prohibited by Worldwide Environmental Protection Organization. PV modules are generated CO2. PV modules also generate CO2 and other GHG at some stages in their life. Pure silicon metal in use in PV panels manufacturing. Throughout the solar cell manufacturing process, a variety of chemicals are employed and various GHG released in different chemical processes are elaborated in this study. When compared to other solar energy approaches, solar PV cell emits the most carbon. Solar plant scrap must be handled with care throughout the recycling process. Solar trash is also classified as electronic waste, e-waste, therefore it must be handled with care during the recycling process. This study focuses on the SHE concerns associated with solar technology. Problem statement. PV solar panels do not contaminate the air while generating electricity. However, the production process of them requires numerous toxic chemicals which are quite hazardous from a SHE standpoint. There are certain issues following the end of a panel's projected life and throughout the recycling process. These concerns will be addressed in this study article. According to a 2009 research by the Silicon Valley Toxics Coalition, the problem arises at the beginning and end of a panel's life. Toxins may be released throughout the manufacturing process, putting workers in danger, and when panels are finally discarded decades later. PV solar cells contain highly toxic metals such as cadmium, lead, arsenic, nickel, and others. Their usage is forbidden by Worldwide Environmental Regulation. Limited E-product cadmium, which is also a human carcinogen, is utilized in thin film cadmium telluride PV modules. The manufacturing process necessitates the use of numerous radioactive elements such as materials used on a large scale is extremely hazardous to SHE point of view. Problem faced with the manufacturing and disposal of solar panels. We cannot use solar panels in large quantities to provide energy similar to that provided by a thermal power plant unless we can handle the garbage generated during panel disposal. Despite the fact that they are employed in small quantities in the panel, several of the materials used in solar panels are rare in nature and cannot be reclaimed. Because many of the compounds do not have a suitable disposal alternative, they are burnt or landfilled, which is very harmful to the environment. In this study, there are two objectives. The first one is to address the safety, health, and environmental SHE impact of solar energy technologies, particularly photovoltaic PV modules, to the sustainability of human activities. And the second objective is to recommend the possible ways to reduce the effect of potential hazard of widespread use of solar energy technologies, particularly PV photovoltaic modules. Scope of limitation includes obtaining facts from reading, conducting a survey, and distributing questionnaire. Significance of the study. This study investigates the safety, health, and environmental effect of solar energy systems, specifically PV modules, on local residents. The global supply of solar energy system has risen significantly due to an immense amount of untapped solar power, eco-friendly features, and the need to address potential energy fuel shortages in the near future. When opposed to traditional electricity sources, solar energy has enormous environmental advantages. However, solar systems emit GHGs, especially during the manufacturing process, and the waste produced by the solar industry is classified as e-garbage and must be treated with care. This analysis is expected to be carried out in order to lower the sheer effect of solar energy technology on mankind by adopting the recommendation proposed in this analysis in order to recover the influence of solar energy system in the future. Literature review. In order to understand the study, we need to understand the definition of the topic, which is solar energy and safety, health and environmental SHE. Solar energy is the use of sun's radiant light and heat to power a variety of ever-evolving technologies such as solar heating, photovoltaics, solar thermal energy, solar architecture, molten salt power plants, and artificial photosynthesis. Safety, health, and environment safety means arranging actions and procedures for identifying workplace hazards and reducing accidents and exposure to hazardous substances. Health means the development of safe, high-quality, environmentally friendly process, working techniques and systematic activities that minimize or reduce the risk of damage to people's health. Environment means creating a systematic approach to meet environmental standards such as managing waste or air pollution, all the way to aiding location in lowering the company's carbon footprint. Solar energy technologies are divided into two, which are photovoltaic modules, PV, known as PV, and concentrated solar panels, known as CSP. There are three types of PV modules, which are monocrystalline, polycrystalline, and thin film. And there are three types of CSP module, which are throw system, power tower system, and dish or engine system. Life cycle assessment for technology comparison harmonization. There are 5 life cycle comparison harmonization, which are carbon footprint, energy payback time (EPR), energy payback time (EPR), energy payback ratio (EPR), life cycle land use (LCLU), levelized cost of electricity. Now, let's talk about the negative impacts of solar energy. To understand the influence of solar panels, consider their life cycle, which may be divided into 3 stages, which are manufacturing, operation, and decommissioning. While photovoltaic solar panels do not contaminate the air during electricity generation, the manufacturing process contains numerous toxic chemicals which are very hazardous from the SHE standpoint. There are certain issues following the end of a panel's projected life and throughout the recycling process. This section will go through this topic. First negative impact is the cost of land. Large-scale solar farms need a large amount of area for installation. This problem becomes particularly acute in nations with already high population density such as Singapore. It is difficult to find affordable land in such nation. The high cost of land will also have an impact on the cost of power per unit. Then consumption might be reduced by improving the efficiency of solar panels or mounting the cells on a rooftop. With current solar panel efficiency, the top roof area of houses in the United States will barely meet 1/10 of the total US energy requirement. The second negative impact is toxic chemical content in solar panel manufacturing. This is the most highlighted impact in this study. Various chemicals are employed in the production of solar panels, notably during the extraction of solar cell. Cadmium, for example, is a very poisonous metal that is utilized as a semiconductor material in cadmium telluride-based thin film solar cells to convert solar energy into electric energy. Cadmium dust and fumes are classified as carcinogen by National Institute of Occupational Safety and Health. accident caused by the discharge of dangerous chemicals into the water system in September 2011 sparked local outrage, eventually leading to the company's closure. Due to the usage of hazardous chemicals in their construction, PV panels represent a concern to environmental pollution if correctly disposed of after deactivation. The unintentional emission of heat transfer fluid, water, and oil from parabolic throw and central receiver system, on the other hand, might pose a health risk. Central throw systems have the ability to concentrate light to travel to levels that are harmful to one's eyesight. The third negative impact is ecological impact. Solar energy installations have a direct influence on local ecosystem and the surrounding environment. Large-scale solar farm development necessitates land removal, which has a negative impact on native plants, animals, and habitat degradation. If trees and shrubs are present at the optimal solar location and are obstructing the sun rays, they must be removed. Special chemicals are used for dust suppressants and herbicides cleaning at solar facilities, which result in contamination of surrounding and groundwater. Interference with aeroplane operation is caused by the high of CSP and the reflected light beam. And the fourth negative impact is decommissioning and recycling of solar panels. This is the final negative impact. After its anticipated life of 20 to 30 years, solar modules pose several key issues. Due to the usage of tiny amount of hazardous materials, disposing of them on landfill is a significant issue for local municipal community. A total of 2,000 T of thin film solar panels are required to generate 10 megawatt of energy. The appropriate collection of scrap panel, safe recycling, and emission reduction procedures should be implemented. Methodology. These are the project flow chart. There are two stages in this project flowchart. The first stage is the issue and problem statement and aim of research. The second stage and the third stage are objective, method, findings, and conclusion. So, in this methodology, the methods that are used for objective 1 are literature review and interview. The second method used are literature review, interview, and questionnaire. By these two methods, the findings that we obtain are list of impact of solar energy technology towards the sustainability of human activities, list of factors that cause SHE impacts, list of recommendation, list of most feasible recommendation, and to spread awareness so that the workers are more cautious about the surrounding and working environment. As a conclusion, discussion of findings, proposed improvements, and implementing the most feasible recommendation. These are the Gantt chart, and expected outcome from this study is to achieve both the objective. In order to achieve both objectives, we will to identify the causes of this SHE impact of solar energy system on local inhabitants. After we identify the causes, we are able to address and list all the SHE impacts that solar energy impose towards human beings as well as the environment. In order to minimize the SHE impact of solar energy system in local inhabitants, this study are crucial. The outcome from this study is to achieve the most feasible recommendation to be incorporated innovative production technologies in improving the PV modules efficiency, increased lifetime, less silicon mass per module, lower use of electricity for the production process, and power recycling would help to lower the environmental impacts. As for the conclusively, the safety, health, and environmental SHE impact of solar energy system on local residents. The global production of solar energy system has risen significantly owing to a large quantity of unused solar potential, eco-friendly qualities, and the need to overcome probable energy fuel shortages in the near future. When compared to traditional energy sources, solar energy has enormous environmental benefits. However, solar energy emits GHG, particularly during the manufacturing process, and the trash generated by the solar sector is classified as e-garbage and must be treated with care. Innovative production method that improve PV module efficiency, longevity, silicon mass per module, usage of less power in the manufacturing process, and appropriate recycling with all assist to reduce environmental consequences. Therefore, this study is crucial, and this study should be carried out in order to identify the recommendation, the feasible recommendation. That's all from me. Thank you for listening.